Before we get caught up in all the math, let's highlight the to-do list for this topic and the takeaways of linear equations. So our to-do list, there were 3 things that we need to be able to do by the end of this topic. And the first is to calculate the equation of a line from various types of information. The second thing we need to be able to do is to solve for equilibrium values for 2 linear equations. For example, the equilibrium value of price and quantity from supply and demand curves. And the last thing we want to be able to do is graph these relationships. The takeaways from linear equations are twofold. The first is that linear equations have constant slopes, and that means that as x changes, y changes by the same amount forever. And the second takeaway is that the intercepts of the x and y axis, if they exist, have some useful and meaningful information beyond a simple number of 2 or something like that. So it's time to delve into the math. Here is the equation of a line. Y is equal to a plus bx, where a and b are my parameters of the equation. A is the vertical intercept, and b is the slope, and x and y are my variables. I can graph these on a 2-dimensional axis where I have y on the vertical axis and x on the horizontal. If I draw a red line, it'll start at A and rise by the same amount, assuming that B is greater than 0. So what does this mean? Let's make an application to economics. So suppose I have values for the level of GDP in the US economy over time. And so I have 3 time periods, 2012, 2013, and 2014. In 2012, GDP is 130 billion US dollars. 2013, it's 140 billion. And in 2014, it's 150. And so that means that each and every year, GDP increases by the same amount if I assume that GDP is characterized by a linear relationship. And does that make sense? Let's take another example with coffee. Suppose you're sitting in the airport and you're kind of stranded and you're sitting outside of Starbucks or something like that, and you start taking note of the number of people standing in line. And for some reason, Starbucks changes its price or the duration of your layover in the airport. And you notice the following information, that when the price is $4, they sell maybe 200 or 2,000 cups of coffee, whatever the number of units corresponding to each cup happens to be. And if the price falls from 4 to 2, they sell more. Specifically, they sell 4. And so here's my data. And what I want to do is see if I can come up with an equation of a line that characterizes this behavior. And my line is going to look something like this. Price is equal to A plus B times Q. And this is what I'm going to call the econ view. It's the view that you will see in micro, which is a little different than what we could call the math view, where I would have quantity is equal to some stuff. We'll explain more about this in a minute. So here's my graph. I have price on the vertical and quantity on the horizontal, but mathematically it's a little weird because Q is my dependent variable and P is my independent variable. So the first thing I have to do is I need to find my slope. To find my slope, I need 2 pieces of information. I need price and quantity in one observation and price and quantity in another. And so I'm trying to figure out how steep or flat is this line. And I'm going to use, I have 2 pieces of information, or 2 data points, and I'm going to calculate the slope using that information. And when I do so, I find out that it's negative. So as price goes up, quantity demanded falls, and it's equal to 0.01. Really important not to mix your P's and Q's to make sure you get a slope of the right sign. So now this is what my equation looks like. I have price is equal to A minus, and I put the 0.01 in for my B value, Q. In math view, it would look something like this. I can graph this. I have P on my vertical, Q on my horizontal, A, the thing I still don't know yet, and I know it slopes downward because of the sign of the slope. But what's A? So I need to find some way to solve for A. And I know that my two data points are somewhere on this line. And so if I can take a value for price and a value for quantity, I'll figure out what A happens to be. So I'm going to take the first. All I'm going to do now is substitute $4 for P, 200 for Q. And this is what I do. I end up with A is equal to 6. My vertical intercept is 6. And so I can add that to my equation and to my graph. And so what are some of the insights I can get from this? Well, the first is that 6, that vertical intercept. And what that says is if Starbucks charges $6 or more, there's going to be no one in line because no one wants to buy it. The other thing is if Starbucks decided to give all that stuff away, if lattes were free, the price was 0, 6,000 would be demanded.